Well, hello, my radio friends. This evening I'm out in my shop playing. I've kind of on hold for projects just yet, so I thought I'd pull this Weston model 788 tube tester out and kind of show you how this operates, um, and what's the pluses and minuses of this particular tester. Well, one thing that will come to mind, it looks to be a much older tester than what it is. This tester actually came out during World War II, and so obviously the meters and so forth, I think, kind of predate that period, so it gives it kind of an older appearance. Um, I have to say, it is a somewhat, I use the word problematic to operate. It doesn't have some of the luxuries that some of the newer, or should say, different tube testers had. The first obstacle, if one could call it that, is one must use patch cords between the tube socket panel and the main tester. There is no connection electrically between here and here other than these patch cords. So in this case, we're going to be testing an O1A, probably the simplest tube you could test. And with that said, one has to physically connect the heater to pins, the plate to pins, and so forth. You got to connect all four leads. You got to connect the connections from the tube socket here, from the 4-pin tube socket to the tester, and that's done via these jumper leads. Now with a O1A is not difficult because it's a simple 4-pin tube. But when you get into the tetros or pentos or more pin-out tubes, it gets to be quite a menagerie of wires across here. But anyway, let's take a look at the procedure, if we may, for an O1A. Of course, we're going to turn the tester on, and we should, of course, see our red light up. And we're going to set our filament voltage, in this case 5 volts. We're going to verify it with a voltage gauge here. Second step is to rotate the plate, what they call the plate voltage adjuster, to 100, and it is. We're going to insert the tube in the tube socket, or in the tube socket, yeah, we'll call it that. And the first thing we're going to do is test for shorts. We move this to our shorts position, and we rotate this knob. If in fact there was a short, as one could attest, might imagine, this tube would in fact glow. So there is no shorts in this tube. So we are going to switch over to meter reading, as they call it, which is essentially tube test. And we've already preset these to 10 and 10 according to the tube chart. So now we do have a reading of sorts, and that's what it states. We should have some sort of a reading on the fan gauge. So now we're going to take this meter reset, and we're going to rotate it, and we're going to balance the bridge, move it ever so slowly, and zero out that meter. Once that meter is zeroed, we press our GM test switch, and we get a reading. In this case, on O1A, the minimum reading is 65, and we are reading right at 80, or very, very, very close to 80. So that is a good tube. But as one can see, it takes a fair amount to do a test on this particular tester. And if I may, I don't know if I stated that this is a mutual conductance tester. So for what that's worth. But it's a tester that I have on my bench. Truthfully, I don't use it very often. I just thought I'd share it with you this evening as I sit here bored, waiting for some parts to arrive. But anyway, I hope you found it of interest. This is a Weston Model 788. One heck of a tube tester. I hope you found it enjoyable. And of course, as always, until next time.